increasing demand for sustainable and environmental-friendly materials has encouraged the use of renewable resource. Waste cooking oil, one of the most abundant waste material generated from households and the food industry. Converting waste cooking oil into valuable chemical products is an important approach to support sustainable development. In this study, the epoxidation of waste cooking oil is carried out using a synergistic acid system consisting of sulfuric acid and tartaric acid as catalysts. Sulfuric acid acts as a strong acid catalyst that promotes the formation of peracid, while tartaric acid helps enhance the reaction efficiency. The combination of this acid is expected to improve the epoxidation process and produce epoxide oil with better properties for potential industrial application. The problem that we usually face before this related with WCO is cooking oil is generated in large quantities from households, restaurants, and the food industry. Improper disposal of waste cooking oil can cause environmental problems such as water pollution and blockage of drainage system. Despite being treated as waste cooking oil still contains valuable unsaturated fatty acid that can be utilized as renewable feedstock for chemical production. One potential approach is the epoxidation process, which converts the carbon-carbon double bonds in the oil into epoxide groups, producing value-added epoxidized oil. However, the use of sulfuric acid alone may lead to excessively rapid reaction rates and undesirable side reactions such as auxiliary opening, which can reduce the efficiency of the process and the quality of the epoxide product. Additionally, its strong acidic nature may contribute to corrosion and difficulty in reaction controls. If we use only a tartaric acid, the RCO value may decrease.
We move on to the objective of this innovation. Okay, so the first objective is to transform waste cooking oil into a valuable epoxidized product using a novel synergistic acid catalyst system. Second, to enhance auxiliary formation through the combination catalytic effect of sulfuric plus tartaric acid. And the third one is to support sustainable chemical valorization and green chemical system. Now, so let's talk about the novelty of this project. Okay, so this project stands out because it uses a unique combination of sulfuric acid and tartaric acid as a dual acid catalyst. Traditional method often relies solely on sulfuric acid, while effective, it is highly corrosive and can damage equipment or create safety concern. So by introducing tartaric acid as co-catalyst, the process reduces the amount of sulfuric acid needed, making it more safer, less corrosive, and more environmentally friendly.
So next we move to the benefit of waste cooking oil by using the synergistic acid system of the sulfuric acid and tartaric acid. So this project tackles global challenge by finding sustainable and environmental friendly alternative to the petroleum-based chemical. So traditionally, chemical products are reliant on the fossil fuel, so which contribute to the pollution, so greenhouse emission and depletion of the non-renewable resources. At the same time, waste cooking oil is produced in the large amount and often discarded improperly, causing the environmental damage. So then by converting of the waste cooking oil, so this one waste cooking oil into the epoxide of waste cooking oil. So this one is epoxide of waste cooking oil. So this project provides a practical solution that addresses both issues. So if beyond environmental benefit, the project creates a economic opportunity by allowing the commercial and small business to collect and supply of the waste cooking oil. So moreover, this project offers a strong commercialization potential by converting of the waste cooking oil, which is usually discarded into the high value bio-based, which is the epoxide of waste cooking oil. So epoxide of waste cooking oil can serve as a sustainable alternative to the petroleum-based chemical in industries such as plasticizer, lubricant, adhesive, coating, and polymer. So this often opportunity to the manufacturer to find the growing demand for the environmental friendly product, which reducing the reliance on the fossil fuel. So thus, with the increasing interest in sustainable and environmental material, so epoxide of waste cooking oil has a strong potential for the economy for the both local and international market. So